So now that we've gone over the relationship between unit rate and constant of proportionality and slope and the fact that they are all just synonyms for one another, let's talk about the four types of slope. And when you're dealing with slope, it's going to be one of the graph of it. We call it a linear equation because it's an equation that forms the line. The reason it's an equation is because it's in that form y equals kx that we saw yesterday with the lemonade and the sugar water, or in the previous video with the lemonade and the sugar water. And the graph of the line is going to happen in one of the following ways. The first way is going to come into play with saying that it's going to be slanted bottom left to top right. And an example of this is going to be that somewhere on the graph it's going to be going in this direction. Now, as far as the steepness of that line, it could vary, but generally speaking it's going slanted bottom left to top right. Second one is slanted top left to bottom right. And that one's going to look like this. Okay, so again, steepness of it is going to vary, but generally speaking it goes in that direction. Next is horizontal, which is your line going this way, because if you think about horizontal, memory trick, you know I don't give many, the H in horizontal has that crossbar. And then that leaves us with vertical, which would be the other one, because in a V, both of the parts of the V, both of the sides point up and down. So these are the four ways that a line is going to travel on the graph. Again, the steepness of it isn't always going to be the same for 1 and 2, but it will be. You'll be somewhere in the bottom left up to the top right, and somewhere in the top left to the bottom right, or it's flat out horizontal somewhere or vertical somewhere. So now let's take this and we're going to calculate slope. We did this yesterday, but let's just kind of go back through and think about it. When you're looking at the graph of a line, you're able to calculate the slope of the line. All that means is, how steep is it? Okay, so it's talking about the steep. So slope is just saying, how steep is that line? Okay, think of a bunny slope when you're skiing. You have the bunny slope, you have the black diamonds. It tells you how steep is that mountain. Now, because slope states how steep a line is, it's got to be a ratio that's written in fraction form. Okay? If you look at this ratio, it should be simplified to all be the same. Remember when we drew the triangles and we ended up simplifying it and hey, we found out everything's the same, or we looked at the lemonade and sugar water and found out they all simplified to the same. So no matter which 2 points you pick, if you pick 2 and everybody else in the class picks 2 different ones on that line, they're all going to share that same ratio. Now slope can be calculated by writing a ratio that counts how far up or down compared to how far right between the 2 points. So notice that up and down came first, and we know that up is positive, down is negative, and then how far right is positive. You technically could say how far left, but we really don't deal with that. If you were dealing with moving in a left direction, left would be negative. And then slope can also be calculated by writing a ratio that takes the difference of the coordinates. So you take the 2 points and you subtract the y's over subtract the x's. Now, we looked at counting between them on the previous video. Now we're going to look at the whole subtraction piece today in this video. We have -3, 2, and -4, 7, and we want to know what is the slope between these 2 points. So these 2 points are on the same line, and we want to know how far apart they are. What is that ratio of the slope? In order to do that, we take our first coordinate, 2 and -3. We subtract 7 and -4. Notice that I did the 2 and the 7 on top, and then the -3 and the -4 on bottom. This is because you want to subtract y minus y over x minus x. Technically the phrase is, or the common way that we remember it is y2 minus y1 over x2 minus x1. So another way we could have done this is 7 -4 minus -3, 2 negative 3. Okay, that's because you're technically dealing with y2 is technically the second point, that negative 4, 7. But it really, in all honesty, order doesn't matter as long as we kept it the same. So notice that in both cases, the y coordinates, the one I circled in green, those are on top, the 2 and the 7. And then the x coordinates, negative 3 and negative 4, are on the bottom in both instances. And that the ones that are the actual coordinates, negative 3 and 2, in the first example, both of those are the first number. In the second example, both of those are the second number. Doesn't matter which way, okay? Doesn't matter which one. So now we can actually go through and do the subtraction piece, and we get 2 minus 7 is negative 5 over negative 3 minus negative 4. We know we're going to have to add the opposite to get negative 3 plus 4, which is positive 1. Now what happens if we go about this the other way? And we can simplify that to negative 5. 7 minus 2 is 5. Negative 4 minus negative 3, add the opposite, becomes negative 4 plus 3, which is negative 1, which equals negative 5. So in either way, we ended up with a negative example. Okay? So in this case, I can tell you that a negative slope is going to be one of the 4. So let's take a look back at the couple pages. And here we have these examples, right? Negative is going to be the second example. This is a negative slope. All right, notice that the line's kind of moving downwards. We can think of it as moving downwards. That is your negative slope. So now, let's take a look at 5, 9, and 4, 1. So we know we're going to say y minus y and x minus x. And we know that it doesn't matter which one we start with, whether we do 9 over 5 minus 1 over 4, or if we do 1 minus 9 over 4 minus 5. And the reason it doesn't matter is because 9 minus 1 is 8, and 5 minus 4 is 1, which we know we can simplify to 8. 1 minus 9 is negative 8. 4 minus 5 is negative 1. Signs are the same, your answer is positive, and you get positive 8. So in either case, we ended up with 8. But again, the green numbers, those y coordinates, those were first. In both instances, the none and the 9. The 5 and the 4 were the x coordinates. I circled them in yellow. Those were the second, or those are the bottom coordinates, because those are the x's. Because remember, we're dealing with rise over run. Since we're talking about how far up or down, that's your y coordinate, because it tells you how far to move up or down. Run is your x coordinate, because it tells you how far to move right or left, but we're thinking primarily right. And then I know that 5, 9 needs to be in either both of those need to be the first numbers, or both of those need to be the second numbers, the numbers we're subtracting. So the first example we did with our 2 coordinates, we got a negative slope. The second example, we got a positive slope. When we come back and look at page 40, we notice that our positive slope is going to be slanted. We think of it as being slanted upwards. That's just kind of how our brains work, is we think of it as being slanted upwards, whereas number 2 was slanted downwards because we read left to right. So if you look at the graph, if you look at the line moving left to right, number 1 is slanted upwards, so we think of it as positive, whereas number 2 is slanted downwards, we think of it as negative. Now there's 2 other examples before we hit those examples on the graph. I'll give you a hint. They may or may not show you the other 2 relationships. The hint is they will. So looking at this next one, we have negative 6, 8 and negative 6, 5. So we have our second coordinates, our first coordinates. So we know we can say 8 minus 5, we know we can say 8 over negative 6 minus 5 over negative 6, or we can say 5 over negative 6 minus 8 over negative 6. So we have 8 minus 5 is 3, negative 6 minus negative 6, if I have 6 negatives and I take away 6 negatives, or we can add the opposite, negative 6 plus 6, that's going to be 0. 5 minus 8 is -3. -6 minus -6, we know that's 0, or we can add the opposite and we get -6 plus 6, which is 0. In this case, we give it a fancy name. We say that this is undefined because you cannot divide by 0. I know that you're looking at it going, well, it's not the same because one's positive, one's negative. However, the fact that 0 is the denominator is what makes the difference. Type into any calculator any number you want divided by 0. Every time you will end up with this answer of undefined, or the calculator will say error, because you cannot divide by 0. This undefined, so when you are asked what is the slope of that line, the answer is undefined, because it's not so much that it doesn't exist, but it is too, you cannot mathematically calculate it. So undefined is going to be a vertical line, and it also means that 0 is your denominator. Okay, so if 0 is your denominator, it's going to be undefined. Now you all are intelligent people. Bet you can't figure out. I bet you can figure out what this last one's going to be. Hey. So we know that we're going to take the y coordinates and we're subtracting them over the subtraction of the x coordinates. So we're going to say the first coordinate could be 7 over 3, because our point is 3, 7, minus 7 over 9. Now we've learned by this point we can do 7 minus 7 over 9 minus 3. We'll end up with the same results. 7 minus 7 is going to be 0, and 3 minus 9 is -6. Or 7 minus 7 is 0, and 9 minus 3 is 6. In either case, we ended up with a slope of 0. And the reason we know it's 0 even though one's positive and one's negative is because we are dividing 0 by some number. So for a horizontal line, it has a slope of 0. And whether or not 0 is whether or not your denominator is positive or negative does not matter. Just means that 0 is your numerator. So the simplified fraction is 0. So this is how you can define and label the 4 types of slope. We have 2 problems left, and that is calculating slope given a graph. Now the first problem, they gave you the 2 points. The second one, they didn't give you the points. So let's do the first one just as a refresher. We have to first count how far up are we going. Well, to get from the bottom point to the top point, we moved up 1, and then we moved over 1, 2. So we moved up 1, and we went over 2. Our rise was 1, and our run was 2. So if we were to continue this, we could say up 1 over 2, and we ended up there. And if you notice, each point on the line is up 1 to the right 2 on to get to the next one. And if you're doing points that are further apart, you would end up with a fraction with larger numbers, but the fractions would simplify to 1/2. Now when we take a look at this last one, we should note that we aren't given any points. So what we have to do is we have to find, where does the line cross exactly? Well, when I take a look at this, I note that the line crosses here, and that the line also crosses here. There is no other point on the graph where the line crosses the coordinate exactly. Every other one is just a little bit off. And if you're needing to see that in bigger, just to make sure to kind of prove it, you can follow from top to bottom to see that there's not really another spot on the line where it crosses exactly. So remember, we count how far up and down to how far right. So looking at the far left point, we're going down 1, 2, 3, 4, 5, and we know we're going down, so it's negative. We then are going over 1, 2, 3. So our answer for the slope is -5 over 3. Because we went down 5, it has to be negative, and then we went over 3. That is how to calculate slope given 2 points and a graph.